All right. So good evening, everyone. So good evening to all audience in our Facebook live channel and also the YouTube channel. All right. So welcome to our ASP Astronomical Society of Penang monthly APOD session. This month, October, we are presenting selected APODs. All right, astronomy picture of the day. Selected APODs for October. So today, together with us for this discussion, we have Dr. Chong, President of Astronomical Society of Penang. And then we have our old friends joining us, Jachin from Johor, right? And Jachin currently is IAO, International Astronomy Olympiad trainer for the year 2021. So starting next week, he will train Malaysian representatives to IAO in 2021. And where is IAO this year held?
IO is online this year, so the team will do it in Penang. Yeah.
Oh, okay. All right. So wish you and your team all the best for IAO 2021. All right. And also we have our old friend, Zheng Yang from Heng High School. And he joined us early this year, I think somewhere in March or February. And that time he just finished his SPM and now he's doing his Form 6 in Heng High School. All right. So both Zhen Yang was the former Heng Astronomy Club president. So both our invited panels, Zhen Yang and Jin, have a lot of experience, have many experience in astronomy. So before we start with APOD today, as usual, if you all have any questions, all right, or any thoughts you would like to share with us, you are welcome to share it through the chat session on both on the YouTube channel and the comment section in the Facebook page. All right, so let's start with the APOD today. Right, let me share screen. This one. All right. So you can see my screen.
Wow, beautiful, like beautiful.
Yes. So this is APOD on 30th of October. All right. The title, Research Aurora. So this is an Aurora. For many months APOD, in many APOD sessions, we always discuss about Aurora. So to be simple, all right, Aurora is the interaction of this solar wind in this with our magnetosphere. All right, so this is an atmospheric phenomena. All right, and this is a green aurora, and this image is taken by this Göran Strand. All right, Göran Strand. So he's a Swedish astrophotographer, professional astrophotographer, a Swedish. So this G in Sweden, they don't have this J, they don't have this g sound, right? They don't have the G sound. So G is pronounced as this J sound. So it's Göran Strand. All right, and this photo is taken in Yamlan. All right, Yamlan over here. Right, it's mentioned over here. All right, there, Yamlen, Sweden. It's not Jamlen, all right, because they don't have the J sound as well. The J is pronounced as the Y sound, so it's Yamlen, Sweden. So this, all right, it looks like the caption said this is a monster face, all right. It looks a bit like the monster face, but to me, I see it like more like a tiger face. Right, looks more like a tiger. The nose is here, and then the mouth is here, and then this is the two eyes. Right, looks like a Chinese tiger in the statues. So anyway, this is pareidolia. All right, which is you see something that looks like some other thing, but in fact have no relation. It's not related to that actual object. So this one. This is it looks like a monster, but have nothing to do with monster. All right. And then this one is actually a panorama of the northern lights, Aurora Borealis. and digitally mirrored. All right, so it's actually left-right mirrored. All right, left-right mirrored. So you see the left side and the right side. All right, is mirror image. All right, even though the top and bottom it looks like mirrored, but if you look carefully, it's actually the top and bottom is two different image. So I suspect it's actually the composite of two image from, because it's a 180 degrees panorama. That means from bottom to up to the sky, and then from the center of the bridge, right, it takes from the left side from the bridge to the sky, and then the other side from the bridge to the sky, and then it combines both into one, and then it mirror it. Okay, so this is APOD today about Aurora, right? A very nice APOD. Next, we proceed to APOD on 25th. Right, APOD 25th is Road to the Galactic Center. Is by Michael Abraham. Okay, he's a professional astronaut. Professional photographer and video editor. All right. So when you see image like this, all right, especially when you see the nebula, very beautiful nebula in the sky like this, okay, most likely this is a composite image. All right, or not most likely, it is a composite image. So in this image, all right, is taken in this Monument Valley, okay, somewhere in this southwest of America, in the state of this Colorado, right? So this is the U.S. Road 163. You can understand it as this is the highway, like our north-south highway. So this is the American highway. So this is the U.S. Road 163, and this is the Monument Valley. And this is a long exposure image, all right? So you see the light of the car. So this is a long exposure image. So we have three sky objects over here. The galactic center, so the Milky Way center, and then we have the Lagoon Nebula. Okay, the Lagoon Nebula are known as this Messier 8. Messier 8, or the new general catalog NGC 6523, which is located in this constellation of Sagittarius, and you can easily spot if you have a pair of binoculars. Okay, and the size is quite big. All right, you see, even though it's something so small, a few dots like this. All right, but in fact, it's the size. All right, the area like this. Okay, is about 50 times 22 light years. That means 50 light years, 22 light years. The size is about that. And because it's very far away from the Earth, so the distance from the Earth or from the solar system is 4,000 to 6,000 light years. Okay. And then we have the 3-Feet Nebula, which we actually had discussed in previous APOD as well. It's known as the Messier 20 or the NGC 6514. It's also located in this constellation of Sagittarius. So the 3-Feet Nebula, we have this massive star, okay, massive stars with this very big solar mass, which is about more than 20 times solar mass, is formed in this 3-Feet Nebula, and it's about 4,100 light years away. All right, and it's also a very big nebula. It have a radius about 20 to 22 light years. All right. So that's it about the APOD for 25th of October. So next, I'll pass over to Jachin to continue with his APOD presentation. Right, so I'll stop presenting.
Thank you, Lai. Okay, so all right, so can you guys see my screen?
Yes, can see.
Okay, so the first picture I'm going to talk about is the picture from the 24th of October. So this is a very festive picture. It's a ghost. It's the picture about the Ghost Nebula. It's also called the NGC 2080, and it's located in the Large Magellanic Cloud, which is a satellite galaxy near our Milky Way. It's not a extragalactic galaxy. It is something. It's part of the Milky Way, and you can actually see it if you are in the southern hemisphere, looking near the the South Celestial Pole. So this is a very festive picture because it reminds us of why we actually celebrate Halloween. And like, I know we don't actually celebrate Halloween in Malaysia, but why is Halloween such a big deal? This is because that Halloween is actually an astronomical day. It has astronomical significance since a long time ago. So why is it on October the 31st? So actually, the Halloween is the midpoint between two major season events. Is the day between the autumnal equinox, which is in September, and between the winter solstice in December. So between September and December, you should actually get the date of the real Halloween around the 7th of November. So that is the real Halloween. But if we follow the modern calendar, we all celebrate on the 31st of October, and that's okay. But if you really want to celebrate, if you want to celebrate Halloween again, or if you want to like uh, you want to celebrate the real reason of why we celebrate Halloween, then the real date is actually the 7th of November. So, yeah, this is a picture by Mr. Muhammad, and yeah, it's actually taken by the Hubble Space Telescope, and the colors are not optical colors; they are just uh, assisted colors that is processed onto the picture. So yeah, thank you, Muhammad. This is a very beautiful picture. And then we have our next picture is from the 22nd of October, and this is a very meaningful picture. So in this picture, you can see there's two special features here. So try to guess what nebula is this, and try to guess also what is this? Is this a plane? Is this a satellite? Is this some meteor? So it turns out that this is the Crab Nebula. So you can actually see from the shape, it's a very famous nebula. You usually see it if you look up, like if you search for nebula, the first one to come out will be Crab Nebula. And it's also called the Messier 1, M1, which is the first object in Charles Messier catalog of what is not a comet. So back in those days, like the back in before high tech astronomy, um, the astronomers they usually want to find comets. They would like to find comets because you can learn a big deal about them when they move around against the stars. So Charles Messier is one of those astronomers that want to look for comets, and he maintained a catalog of objects that are not comets. So objects that are fixed against the background of the stars that won't move like comets. So this is his first entry, Crab Nebula. But why I say this picture is meaningful is because there is a comet right here, just beside the Crab Nebula. It looks quite like far from each other, but actually this is a very small field of view picture. In fact, here it says yeah, it's just 2 degrees. So it's a very small area of the sky. So they are actually quite close to each other. And this comet is actually not just any passerby comet. This comet uh, has very good scientific value to the humankind because uh, back in the 2010s, NASA sent a mission to this comet. This is called the Rosetta's comet, and they actually they sent this is the comet that they sent an orbiter so that it is the first spacecraft that orbits a comet. So this is that comet, the Rosetta comet. In fact, I have a picture right here, and I believe some of you guys can recognize like these are actually quite famous pictures of Rosetta. Yeah, and it turns out that NASA actually purposely crashed their their spacecraft and landed into the comet when they finished their mission. So yeah, there's actually two robots in the comet when you look at the sky. Yeah, so yeah, it's a picture taken by Jose. Thank you very much. It's really a very beautiful picture. Yeah. And next, we have our another spectacular picture from the 20th of October. It's taken by John Krause, and it's it's spectacular. It's a beautiful long exposure of how the rocket fires. So this rocket is the Atlas 5 rocket, and what it's carrying is actually a very important thing. It's called the Lucy mission. So what Lucy does is it's going to reach to the orbit of Jupiter, but it's not going to visit Jupiter. It's going to visit the asteroids at the orbit of the Jupiter, which is not close to Jupiter. So if you know a bit about celestial mechanics, there's actually a few stable points in the orbits. So let's say this is Jupiter, and if you draw a equilateral triangle, so 60 degrees away, you have the Trojan asteroids. These are also the Trojan asteroids, and yeah, so this is also called the Lagrange points because this is where the asteroids or any other thing will be stable over there. That means that they will be trapped there. If you enter this zone with a small enough velocity, you will stay there until something else pull you out of it. So this is why they sent Lucy to the Trojan asteroid because they want to figure out uh, what 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 materials are inside these asteroids because they are so well preserved. They are so isolated in such a place that if we study them, we can maybe get a glimpse about the origin of the solar system. So yeah, this is a very beautiful picture and a very beautiful mission behind this picture as well. Yeah, and also the bit of trivia knowledge is why is it called Lucy? It's named after the famous fossil Lucy. I think there's also a movie that is named after Lucy. So yeah, Lucy is the a fossil, one of the groundbreaking fossils of humankind. It's a female fossil, and it's linked to the increase of brain size when humans walk on two legs. So yeah, just a bit of trivia knowledge, but yeah, it's a very beautiful picture. And finally, I have my last picture from the 19th of October. It's a it's very flashy picture, a lot of stars, and in fact, this is a globular cluster. It is called Paloma 6, named after the observatory site that discovered this. So Paloma 6 is a globular star cluster, and it is actually a very special globular star cluster because it limits the age of the solar system. So what do I mean? Globular star cluster like Paloma 6 are actually the oldest objects in existence in the Milky Way because usually if you are a new cluster, you are usually an open cluster, but globular clusters are really old. Like the stars in globular clusters, they are very old. In fact, what's so special about Paloma 6 is that they are estimated to be about 12.5 billion years old, and the universe itself is currently approximated to about 14 billion years. So this also gives us uh, a lower limit to the age of the universe and the age of the Milky Way as a whole. So yeah, this is why Paloma 6 is so special. And there's actually a very good research paper written about it. They talk about how they use data on Paloma 6 to derive the physical characteristics of the global cluster and what we can learn from the universe on it. It's quite a lengthy paper, but if you have time, I would recommend you to read it. So yeah, this is a picture taken by the Hubble Space Telescope, and yeah, it's a very spectacular globular cluster. So I think that's all from me. So I think I can pass on to our next presenter.
Yes, so next one we have Zhen Yang with us, right, for the next APOD.
Okay.
Please.
I'm sharing my screen. Can you all see my screen now?
Yes.
Oh, okay, thanks. So My first APOD picture is on the 18th October, which named Earth-shine Moon over Sicily. It's taken by Dario Granoble. So this is what we call the Earth-shine Moon. And then here have a bright star, bright planet here, Venus, and this is called Juba. So there is something like silent D. Okay, we didn't read out the D. And here have a red star is named Antares. So let's start from the what is called Earthshine. So it actually is is a phenomenon, uh, or also we call Earth light and Da Vinci glow. This is because that 500 years ago, this is discovered by Da Vinci. So we can see the moon because it reflects from the sun, but this phenomenon of Earthshine is not directly from the sun. It is the sunlight reflecting from the earth is something like this. When the sun comes to the earth, and then the light will reflect back to the uh, moon, which the dark side, and then reflected again to the earth. Then we will see the earth shine. All right. As and if there are more clouds, they will reflect more lights than the sea and the land. Yes. Another thing here is the Juba. It is a primary star in Delta Scorpii binary star system. So that means that there are two stars orbiting around their center. It is located at the head of the Scorpius constellation. Is about in the forehead of the constellation. It is about 400 light years away and have a 2.3 apparent magnitude. Is quite dark lah. It's not like negative something which is very bright like Venus. Next, Antares here. Actually, it is red supergiant, so we can say it red in color, and it also is the heart of the constellation of Scorpius. That means here is the head, and here is the heart. Actually, it's quite long distance between them, I think. Yeah, and then below is the city in Sicily, Italy, called the Palazzolo Acquede. Is um this country have a very long historical, which they start their Asian before century, and they mainly now is doing agriculture, but seems like it's a quite big city there now, I think. Yes. So let's proceed to the next photo, which is 16 October, and the name is the Mona Lisa. Yeah, it's something about Mona Lisa, which the Da Vinci draw. And this is made by Ganis Garcon and Marcella Gluli Piss. Okay, first we can see here have many color of moon, but in our daily life, actually we only know moon only have about one color, is something like white or gray. But how come here have so many colors with something purple, blue, orange, yellow, or something red? Okay, this is because of our atmosphere of Earth, the changing of atmosphere condition, or sometimes it's the alignment geometry of moon, earth, and sun. And maybe the place is polluted, I mean air pollution, then we will see the different color of moon. Of course, not the moon change color, but is our uh, scene. It's something what we see. So as example, when our atmosphere is thick or full of dust or any particle particles, then we will get a longer wavelength, which some like red or orange, and the shorter wavelength will be reflected out to the sky. That's why we will see the color will go to red or orange, but not blue, green, or even white. So below here is what we just say the APOD is the Earth shine. I mean, yeah, Earth shine is we can see dark side here, and then is the moon light, which we normally see is the back part here. All right, so when we going to the smaller, we can see that actually it's look like a Mona Lisa. So what is Mona Lisa? Okay, is this picture. It cost about USD 800 million. It is the one of the most valuable painting in the world. So it's now in the museum. Yeah. And then we also can realize that the moon here, we only can see one side of it. This is because the moon is always face one side, face Earth due to the same period and rotation. Due to the same period of rotation and revolution of the moon. Yes. So the next airport photo on 12th October is this fireball over Lake Louise by Hao Qin. Okay, this picture actually special is on this white thing here. It's like a missile from outer space is shooting the Earth. Of course, it's not missile. So this is a fireball captured by the astrophotographer Hao Qin by accident because we actually cannot predict or track when or where this fireball will strike or come into the Earth. So what is a fireball? Yes, it is a meteor which brighter than any planet as well as bright enough to have a shadow. So here we can see the shadow of the fireball or the meteor, right? Yes, of course the lake is quite clear to have a shadow with not polluted or all full with rubbish. Yes, and then here have a long tail in behind it. Yes, and then next, this lake is called Lake Louise, or also known as the Lake of the Little Fishes. It is one of the famous lakes at Canada. So actually, we can say two sides is all surrounded by the hill. So it is middle of the hill. So there have a very luxury resort built in 20th century, but in this picture we can't see it. Here we said this is the Lake Louise and the resort is here. So there are mainly is a tourist attraction where you can go for your holidays or have trekking beside. It's a it's a quite a good place for holiday, go for relax or even go for have a different kind of lifestyle there. Yeah. And then here have a short video which taken by the astrophotographer.
Wow.
Yes, that only takes about maybe 1.5 second or 2 second. Yeah, this is the astrophotographer is taking the time lapse of the Milky Way and suddenly get the picture of the fireball. So need some luck lah to see a fireball or to capture a fireball. And for my last APOD picture, which is 9 October, this is 50 light years to 51 Pegasi and by Jocelyn Delmas. So this is 51 Pegasi, but here got a shortcut 51 Peg. And here have the Pegasus constellation, which is the horse with wings. So this actually have like something square, rectangle shape, and then here is the legs here. And then here we have the Andromeda constellation and Aquarius constellation. Of course, here we have see a very quite dark spot here is the M31 star cluster. So actually that day they took this picture is in a hazy night. It's not clear, but also can see so much of stars and maybe the star cluster. Okay, let's start with this observatory. So this is Haute Province Observatory, which the shortcut is OHP, is in France. So was extinguished in 1937. It's a quite old uh, observatory, which is in dome type. Now is actually used for national facility of France. So it built at a highland. That means is in a higher place because there is 60% night are suitable for astronomical observation and got 100 over days are totally without clouds. That means the astronomer are very it's very easy to have their observation or have their astrophotograph. And then this observatory have 4 main telescope, but one of the biggest one, which is this, is about 1.93 meter reflecting telescope. And here we can see a working place. Actually, is a control for the telescope. So this telescope is totally computer control. I don't think it can be manually because it's so huge. And then this and then the astronomer at that observatory also won the Nobel Prize in Physics 2019 using this telescope, which taken or discovery the 51 Pegasi b. So later we will talk about that. So let's start continue with the 51 Pegasi, which is the small dot here. It is a sun-like star. That means it got many things like mass is some like star. Like our sun, right? But it's older than our sun, about 1.5 million years older. It's quite old, and then it is 50 light years away. So yes, and then apparent magnitude about 5.5 is quite dark for us to observe or take the photo or using our eyes. And then it has one and the only one exoplanet, which named 51 Pegasi b is orbiting it. So exoplanet is the planet outside our solar system. So this 51 Pegasi b, which let the astronomer won the Nobel Prize. So what's so special about that? So it is the first exoplanet discovered orbiting a sun-like star using spectrograph, and then it has a mass at least half of the Jupiter's mass, and orbital period is 4.2 days. And actually, it has a very fast orbital speed, is 136 km per second. in our solar system, there are no the planets. Yeah, no planets have achieved this speed. Okay, mostly our planets is less than 100 km per second. And then this 51 Pegasi B also have a prototype of planet called hot Jupiter. So hot Jupiter actually is a type of planet which is gas exoplanet, and they have a physical similar to our Jupiter. Yes, that's all for my parts. Thank you.
So thank you, Zhen Yang. So next we have Dr. Chong to proceed with APOD on
thank
the
you,
16 and 7, right?
Thank you, Zheng Yang. Okay, so I'll present now. Can see the screen, huh?
Yes, yes.
Okay, so I will present the first two, then I pass over to you, Lai, my first two.
Yeah.
So it's in the center, 2021 October 17. Now this one is very important in science, you know. Okay. So I read first. 17 October, you see this interesting, yay, 4 stars. The Einstein cross gravitational lens. Of course, this is presented by our Dr. James Rhodes, astronomer in Arizona State University. Now, this Arizona State University is the city of Tempe in Arizona State. These are all big American consortium of observatory that took this picture. This is not from Hubble, from ground-based telescope, big one on the ground in America. On the right is NSF, National Science Foundation, the big one. So basically, you see something like that, all right? Now, this is a long story, yeah? Now, remember, in 1915, Einstein came out with the general theory of relativity. And 4 years later, in 1919, they already saw the bending of light by gravity in the 1919 total solar eclipse, all right? You have this Sir Arthur Eddington, Astronomer Royal of England, sent 2 teams, one to West Africa, one into East Brazil, and he took the total solar eclipse and saw that the stars in the background from the Hyades star cluster are bent by the gravity of the sun, just a bit, and that made what? Einstein world famous. But that is the bending of light by a single star, our sun. But this is not. So this is a Einstein cross because it looks like 4 stars like cross. So I show you now. This is a small scale picture. This is a bigger picture, right? So basically like that. Far behind this in between this galaxy, there is this quasar. Quasar means quasi-stellar object. Basically, it's a black hole that is swallowing a lot of material and giving a lot of light. So it may look like that. So you have here on the top left-hand corner a galaxy, a quasar, giving off light, and we are here on the Earth. So the light from the quasar passing through, and in between there's a galaxy in between. This is not so bright, but the light from the quasar is bent by the gravity of this in-between object, a galaxy. So what you have here on the left, it takes a longer time to come to the Earth and not shorter. So here on the left is one spot law. Here on the right, one spot law. But on top, there's another one, and big bottom is another one. So basically, you have, all right, this is passing over the in-between galaxy, passing below the galaxy, passing to the right, left. So basically, the light of the quasar. Now, quasars usually are cosmological object, meaning billions of light years away. So the quasar, this object is a constellation of Pegasus. Okay, so the quasar light is bent by the in-between galaxy to give 4 objects, as if the in-between galaxy acts as a lens, not a glass lens, gravitational lens. All right. So this was predicted by Einstein, but not seen until 1985. 70 years after general theory of relativity was proposed, they saw it occurring at a galactic scale. So you see, these 4 light spots are from the same object, from the same quasar. But there's something very interesting, you know. Usually they would not say in the textbook. So what I'm saying is this, you see here. So here on the right hand side, the light travels shorter distance, arrive to the Earth law. And here take a longer distance. Now remember, this is a galaxy, you know. A galaxy can be 100,000 light years in diameter. So the light here takes a shorter time to reach than the light on the left. That means what? That means the light on the right side comes earlier than the light on the left. That means that imagine you have a quasar behind there. Here, every spot of light here is the quasar at various time in its lifetime. That means here, the one on top, wait, the one on top means here means the light here arrived, let's say, at a certain time. The second one at the 3 o'clock is the light arrived 1,000 years later. At 6 o'clock, the light arrives another 1,000 years, even longer. And at 9 o'clock, another 1,000 years later. That means the fourth spot is various pictures, but in a different time. Like this, so this is very weird, you know. So imagine here, instead of a galaxy bending the light, let's say you have now this is called galactic gravity lensing. Let's say we have what's called gravity micro lensing. That means instead of light being from a galaxy being bent, imagine that's a human being very far away, and the light passes through a certain object, like maybe a stellar object, a black hole. So the light from the gravity from the black hole can bend the light. So maybe here in the top on the top means you can see the time when the baby was born so many years ago. All right. And this is 20 years later, the baby has become a young man. But you can see them both together. Just born at 12 o'clock, at 3 o'clock, 20 years old. And then below here is, say, at 60 years old, when become a famous scientist. And at 9 o'clock, he passed away. So the whole life history of the person at 4 points in his lifetime shown at the same time. Fantastic. And this is not yet over. No. Now, what we've seen here is this gravitational lensing at point. Sometimes you can also have the alignment of this galaxy, and in between galaxy and Earth is exactly straight. What happened is you can see an Einstein ring, a ring around it. So imagine, let's say Einstein ring is applied to a human being, and that means behind there's a human being, and in between there's a black hole. So you have a ring it's a ring of light, and right from the ring of light you follow on a clockwise direction. You see the various. It's like playing a film that was just born 1 year old, 2 year old, 3 year old, until 100 years old pass away. So the whole lifetime of a person's life is all captured in a single picture. This is what. So this is called the weird universe. So remember, the truth is stranger than fiction. All right. In this case, the Einstein cross. Right. So now I pass to you. Right.
Yes.
I pass to you first. No.
Yeah, so
okay.
you have one more.
Okay, I got one more. 6. Okay, sorry.
Yeah, but before that, I'd like to make a comment. So if we manage to see all the lifetime of the people, we can travel over there. We can become the fortune teller.
Yeah, can. You can. That'd be great. Yeah. Yes, sir. So this is great. So this is very weird, you know. So Einstein really turn the whole understanding of the universe upside down. So 6th of October. Okay. So this is M43. M43 is basically bigger, smaller. So this is what? M43 streams to Orion. So this is a Finnish astrophotographer. I hope I can pronounce it correct. This is Jari Sokonen, one of the most famous astrophotographer from Finland. All right. So basically, M43 is this one. So M43 is basically this part, the dusty part. Of course, M42 is the Great Orion Nebula. So they never show what telescope he used. So basically, this is he took a picture of M43 here, and this is M42, and this is of course part of the Orion molecular cloud complex. So this is a Orion molecular cloud. So this is what molecules are. So the space is full of molecules, you know. Remember, recently someone posted in our group that they found somewhere in the Milky Way there's a cloud where you have trillions and trillions of swimming pool of alcohol. So these are all molecular clouds. So basically, they are found in space using radio telescope. They studied the spectrum of the rotating molecule there are many species of molecule, from simple molecule to very complex molecule. So this one you see all the so basically, according to I don't understand what he explained. So he's saying that all those dust cloud, looking dust cloud, not dust, it's actually clouds of hydrogen gas. This dusty thing is actually hydrogen gas. All right. So this streams of Orion, and this is about 1,600 light years away. And what does it mean? If we wait long, now remember Hubble many years ago was sent up, already found inside the Great Orion Nebula. Listen carefully, few 100,000 protoplanetary disks. What are they? Stellar nursery. That particle bintang, meaning the clouds of gas and dust collapsing, given long enough time, new stars, planets born, maybe aliens born. So they are born inside here, and 42, few 100,000 protoplanetary disks. And of course, inside here is our famous trapezium cluster, right? So like this. So imagine somewhere here, about 10 light years, there's a molecular cloud collapse to form a star, and then the planets. So from all the research on it, not all the dust and the gas will form the star, no, and the planets. Only 1% only. So in a sense, our solar system collapsed from the molecular cloud that formed the sun and the planets. But the 99% in the original cloud gone, was not successful. Only 1% of the cloud successfully was born to give the sun and the planets. All right, this is okay. So all right, now I pass over to you.
Okay, so it's me again. Let's proceed.
Okay.
All right, let's proceed to APOD 5th of October. Okay, so this is a photo taken from the South Pole. All right, so taken by Martin Wolf. He's actually a German researcher currently in the South Pole. All right, the Ice Cube Neutrino Observatory. So the Ice Cube, this is a special. They call it as the Ice Cube. All right, because it's located in the South Pole and it's cube. So this ice cube is not the ice cube that you have in your teh tarik or in your kopi ice. This ice cube is the observatory. It's the most expensive ice cube in the world. All right. So this is the most expensive ice cube in the world. It support the living of this the scientists exploring or doing research in South Pole. So this is the ice cube. So let's go back to the APOD. Yeah, so this is an image, all right, taken by Martin Wolf in the ice cube. So there's something special about this photo is, first of all, this is the sunrise at South Pole. Now the northern hemisphere is experiencing winter. So that means the southern hemisphere starts to experience summer. So summer just begin in the South Pole. That means sunrise in South Pole is not long ago. So based on the caption, we know that this image is taken somewhere in September. Right, in September. Okay, in September. And imagine this. If our Earth, we don't have atmosphere, right? We don't have air on the Earth. So if you want to observe sunrise at South Pole, all right, so after the winter and the spring in South Pole, and imagine that if you want to observe sunrise, all right, when you will observe sunrise, all right, you will observe sunrise actually during the equinox, right? And equinox is somewhere in September. But the fact is, our Earth, we have a lot of air, we have the atmosphere, so we have the atmospheric refraction. So the atmosphere, the air is actually like a lens. It have the effect of refraction. So in fact, you do not need to wait until equinox to observe sunrise at South Pole. You can actually observe 2 weeks, around 2 weeks earlier before the equinox. You can start to observe sunrise. And when it is summer in South Pole, that means that you will have a few months of sun. All right. So this is the time that the scientists will go to South Poles to explore, to do their research in South Pole. So what does this ice cube do? This expensive ice cube, what do they do? Sorry, what do they do in this ice cube, right? So one of the study is this, they search for neutrinos, And also they also have indirect dark matter searching, and also detect detect galactic supernova. So why studying neutrino is so interesting? Because that if you study at South Pole, you study the neutrino from a point source, right? Because a point source neutrino could help to explain the origin of the highest energy cosmic ray. So this is the intention of why they wish to study neutrino. All right. So usually this ice cube will operate from November to February. All right. And because it's summer over there, so they will travel. So scientists will travel there and then will live there for a few months. All right, from 3 to 6 months, 3 to 6 months, depending on their research period. Of course, there are some scientists that live longer over there, which is about 2 winter and 1 summer, which is about 15 months. All right, there are scientists live longer over there, but then usually they will not stay there for that long, right? They will just go for 3 to 6 months. So this is sunrise, and something interesting about this APOD is this over here. So you might realize that there's a green flash on top of the sun. All right, green flash. So this green flash, you can only observe, all right, before sunrise. All right, that means before the sun came up from the horizon, or after a complete sunset. That means the sun disappear from your view. All right, and this green flash is only only occurs for a very short period, a few seconds only. All right, so there's a development of this green flash, all right, taken in this at the sunset in San Francisco. So slowly, all right, so after the sunset, before it totally disappear in the horizon, all right, just a few seconds before it disappeared, then you can see the green flash is over here. All right, so slowly you will have the we have the green flash. All right, so this is the development. And the exact another information stated in the caption over here is the exact south pole is actually a few meters from this antenna, right? So this is a communication antenna, a few meters on the left. That means the exact south pole on the earth is somewhere here. All right, of course there's no marking over here, so it's estimated somewhere here because it's just a few meters away from this antenna. All right, and also in the image credit, it mentioned Alice Allen. So Alice Allen is a professional astronomer in this University of Maryland, and she was this APOD evaluation. She was in this APOD evaluation and advisory committee in the year 2015 to 2018. So that means APOD selection, she did involve in some work in this APOD selection in this year 2015 to 2018. All right. So next we proceed to the APOD on 4th of November. 4th of October. This is we call it the NGC 4676 when mice collide. So this APOD is known as mice because these two galaxies, they have a long tail. Right over here is have a long tail. It looks like a mouse. So there are two over here, two galaxies. So it looks like two mice. So that means mice collide. All right. So this is an image taken by Hubble telescope, and then processed by William Osling, an astronomy enthusiast, and also an astrophotographer. So this is NGC 4676. There's two spiral galaxy colliding together. All right, and they are about 300 million light years apart, and they begin to collide and merge. So the collision doesn't mean like it collide and then it just merge together. So it will first collide, all right, collide, and then it will like pass through, and then the gravity effect, all right, between the difference between gravitational pulls on the near and the far part of each galaxy, and then it will come back again. So eventually, after the collision, all right, after some time, all right, after it go pass through each other and then come back again, and then a few times, then it will form a giant elliptical galaxy. All right, so this galaxies is located in this Coma Berenice, the Queen's Hair, right, on the north of Coma Berenice is somewhere here. So somewhere here. So this is the Coma Berenice, and then this is somewhere here. All right. So there are two galaxies, and the naming. All right. The whole thing, the whole collision is known as NGC 4676. But each galaxy, each spiral galaxy, we have NGC 4676A and 4676B. So the top one, all right, which have some dark markings over here in the core, right? And then we have this on the tail, starting out blue and then slowly ending with yellow, all right? So this is the NGC 4676A. And then the one with two blue arms is the NGC 4676B. All right, so the whole thing, the whole thing consists of two galaxies known as NGC 4676, and then to differentiate further, all right, or to categorize them, we have A and B. Both are spiral galaxies, but after they collide, they will form elliptical galaxies. The same goes to our Milky Way. All right, a few billion years later, about 4.5 billion years later, our Milky Way will also collide with this Andromeda galaxy, and also our final fate of the Milky Way will be a giant. Currently, we are a bar spiral galaxy, and then after that, after the collision with Andromeda, and also maybe the triangulum galaxies will involve as well. Then we will form a very huge elliptical galaxy. So that's it from me for the APOD or for 4th of October. Next, I'll pass over to Dr. Chong.
Thank you, Lai.
Yeah.
Okay, so the first one showing now is October the 3rd. Okay, you have this holography principle and a teapot, and they never mention who characterized. So basically, this is not beautiful astrophotograph. This is explaining a concept, a very fundamental concept in our standard model of the universe. All right. So basically, if you see here, all right, this is the so-called hologram. So Lai, if you want to look at it, normally when you see an object, our two eyes will look at the point. No, this is your right eye looks straight ahead to the right. Your left eye looks straight ahead to the left, like that. So after, to me, about 5 times, I go, hey, if there's a 3-dimensional view, so this 2-dimensional picture pattern will collapse to a 3-dimensional view, and it looks like a teapot. So on the left is the handle of the teapot, on the right is the spout, the mouth of the teapot. So you tilt the left-hand side, so on the right side, the tea will flow out lah. So this is a teapot. So this is called the holographic principle. There's not much detail here, so basically like that. In 1999, the Dutch theoretical physicist Gerard de Hoop and his PhD supervisor, Professor Martinus Bergman, won the Nobel Prize in Physics for the study on this gauge theory, superstring, and this what we call this superstring, and this what we call holographic principle, right? So in this holographic principle on the electroweak force, we say that if you look at the universe at the lower dimension, which is now 2 dimension, you can get information about higher dimension. So just like I said, if you look with your 2 eyes straight like that at a 2-dimensional object here, you see a 3-dimensional object pop out, right? Like a teapot lah. Behind is a background, in front is a teapot. So that's the principle. So they say that actually our universe we see now is a certain dimension lah. Whatever you say is a 3 plus 1 dimension. But encoded in it is a holographic principle, means that actually there are higher dimensions in it. we can discover. So this is part of our what? Electroweak theory, standard model of cosmology, gauge theory, right? Very powerful theory, All right, holographic principle. So the thing is this: that the holographic principle really is true for everyone. For all cases, the scientists are still not certain. They're still working on it. So now you see a lot of people talking about holographic principle. You study the universe at a certain dimension, 3 dimension, 3 plus 1 dimension, you can get information about even higher dimension. Okay, holographic principle. We go to October the 2nd, the last picture for this month's APOD.
Wait, I actually wonder,
Yeah.
actually from our audience, actually who actually managed to see the teapot?
Okay, so now I show again live. Can you see the teapot? I can see, no?
I cannot see. I stare for a very long time. I cannot see the teapot.
Don't look at my presentation is small. Look at your own laptop one. You can see, see?
Uh-huh.
You have to go further away. Now you can see already. That day within about 10 seconds I see. But the thing is, normally people like to see the eye will all point towards the center. Now you don't know. Right eye looks towards the right, left eye to the left and parallel direction. You can see a teapot there. Can you see a teapot? Can you see it?
I try again.
Now, the idea is, if you bring your eye too close, cannot. It might be. But actually, this holographic thing, you look in a 2-dimensional object, you see that 3 dimensions. They are done for so many kinds of things, beautiful, So I can see it there. It's a teapot. So the mouth of the teapot is on the right, the handle is on the left, and the cover of the teapot is on the top bar. So you tilt it from your left hand, you tilt it, then you tilt, the tea will pour out from the right. That's what I can see. So live later you try and see. So this is holographic principle. Can you see?
Can Zhen Yang and Zhe see the teapot?
Okay, try again. Justin, can you see the teapot? Or on your screen? Now, the teapot will appear in the center of the screen, And when it appears, you say, oh, you're so beautiful. 3-dimensional teapot. Of course, the teapot is not a teapot. Teapot also got small patches of color all built up together to form a teapot. All right? So that's it. All right? So this is our holographic principle. All right? From a lower dimension we see in our present universe, you can get information of higher dimension. Now, remember, like we all say that according to the superstring theory, there are 2 possibilities of a universe. Your universe can be actually 10 dimension or 11 dimension. So if our universe is 10 dimension, let's say, so now we have 3 dimension of space, 1 dimension of time, 4 dimension. So that 10 minus 4 is 6. So the 6 dimension that you don't see are the compactified dimension. Humanity is not powerful enough, not intelligent enough to be equivalent to detect the 6 unknown dimension, right? Or even 7 dimension. So according to superstring theory, there are possibly either 11 dimension or 10 dimension. So we only can sense the 3 plus 1 dimension, 3 dimension of space, 1 dimension of time. So we can only sense 4 dimensions. Actually, there are 10 dimensions or 11 dimensions. So it's either 6 dimensions or 7 dimensions. Until today, we believe it exists, but we have not discovered it yet, not detected it yet. Okay. So now we go to our October the 2nd. Okay. So October 2nd here is, there's nothing much about the science behind it. It's just a beautiful part. So a light and dusty night, I let you have a look, by our Rodrigo Guerra, an astrophotographer from Brazil. So basically, this Roberto, he went to southern Brazil. Remember, Brazil is a huge country, All right? So if you go to southern Brazil, it's what? This is the southern sky, Southern Cross, Large Magellanic Cloud. So this is the southern sky. Of course, you see the Milky Way rising over the tree here, all right? So basically, here, he basically is that because this is taken in September, all right? So it's our vernal equinox, our autumn equinox. So what happens? So when you see the autumn equinox, the galactic plane of the Earth is here. So this is what our zodiacal light. So basically, what is zodiacal light? Zodiacal light is when the original protosolar nebula collapsed, so from the sun and the planets and the asteroids and so on, comet. Some of it failed to form the planets and the sun and so on. So what? There is a plane of dust orbiting the sun. So basically what? Imagine you are alien spacecraft from Omega Centauri, our nearest star system, coming towards the sun. 4 light years, 3 light years, 2 light years, 1 light year, half a light year. Let's say you are about 1/10 of light year from the solar system. Hey, our sun has a ring, a plane of dust. So our sun has a ring. And where is the Earth and the planet situation? Our Earth is buried in the dust ring of the sun. So the sun also got a big dust ring. And all the planets are buried in the ring. So basically, when you go for vernal equinox, the evidence of this zodiacal light is very clear. You can see. All right. It just happened that you have this Venus here. Someone say no lah. This is the sunlight. No. Of course, this is taken in early morning before sunrise. The sun is still below horizon, but you have to believe that even if the sun is far below horizon, already you can see the zodiacal light. So as the sun comes out, you can see more and more zodiacal light. So this cone of dust here, zodiacal light. All right, with this Venus here and the southern constellation here, beautiful picture. All right. So this is proof that our sun is surrounded by a ring. All right. So next time you say, hey, come, look at Saturn. Wow, I can see Saturn ring. And do you know, boy, we are now in Kapasing Drive in Penang on the planet Earth, and Earth is inside the ring of the sun. The sun has a dust ring. But of course, where we are near the Earth, the distance between the particles are quite far away. We don't see it, but we are far away. Let's say, I would say that maybe you are distance of say Neptune or Uranus, and you look back at the sun, maybe you can see the ring of dust orbiting the sun, and our Earth is buried in the ring. All right. So this one you can see. Okay, I'll repeat again. A light is here. All right, the zodiacal light, and the dusty night. Okay. So now, light. Any question? Okay, any question? Light, on your microphone. On your microphone.
Sorry.
Okay.
Yeah, so far no question from both Facebook and YouTube. Okay. And Jun Kiet make a comment that he can see the teapot.
Yeah. Look at your eyesight is normal. Sorry, most of the people, why they don't see it, they look at it, sorry, like cock eye. Cock eye means you don't see it like that. You see either like that or like this. Towards the point. But you look this way, you come out, the teapot very clear. You later on, I'll suggest that you come close to the screen and go further away. Hey, the teapot is there. And when it comes, the first few moments, a bit giddy, this is it. Our USM museum got a lot of this type of pattern. 2D become 3D. Yeah. So our general comment this dance selection very good. It covers all kinds of topics. Very good.
Yeah, and two very interesting topic: the gravitational lens and the teapot.
Yeah. Gravitational lens. Actually, I can speak the whole hour. All right. So this one I remember. I have been waiting for many years. When are they going to see gravitational lens for galactic scale? For the single star god, the sun, 1919, total solar eclipse. But they only came out 1985. And the first one they found, gravitational lens, more and more. So there's so many. They are talking about Einstein ring also. So the thing is this, some people say, no, I can take a picture of a baby born, then let's say 20 years old, 40 years old, 60 years old, then grow old and so on. But you say in astronomy even more weirder. I can show you a gravitational lens where the whole of history of the human being is in the ring. So beginning at 1 o'clock, 1 year old, and you go older, all there, the whole history of the person is there, And in the one picture, the same picture, in one time, you can see the whole history of the person there. So what? Weird lah. It's possible. Yeah. Yes, like that, But of course, the other one is, they asked our Stephen Hawking, he cannot answer. Traveling back in time, can I have a gravitational lensing where now I see I go back. There's like this lah. Before I was born, before my father, mother met, go back. Now, traveling forward in time can, traveling backward in time until today, the scientists cannot say it can occur. Forward in time can, backwards in time, they say, they never say no, not confirmed yet. Yeah. Okay. So now maybe I read up like what's coming up in our event. Okay.
Yeah.
So now we have on the 13th of November, Saturday, we have our Astro Cafe, choosing your first telescope. So anything you want to ask about telescope, our CK, Lim Chung Kiat, will answer you. Okay. And then of course on the 20th November, Astro Chat, Saturday, apa di langit? That's a topic here. All right. And of course, our next airport tour is 27th of November. All right. And interestingly, on the 5th of December, Sunday, night sky imaging workshop for beginners. All right. There'll be charges like I was reading before, but interesting, night sky imaging workshop for beginners. For ASP members, free lah. So Lai and I can attend. All right. And of course, we have other events, but this is for our members. But never mind, I hope our members are listening. So 11, 12 December, we are planning a field trip to Wang Kelian in Perlis. The beautiful 1,000 feet high hill where we can do astrophotography here. 11, 12 December. All right. And then on the 13th December, this is not our society event. In the USM Museum and Gallery, we are organizing astro-tourism event. Not confirmed yet, the 13th December, the whole day event plus night stargazing and Gemini meteor shower. And then on the 14th of December, our own society will have in Lim Chung Kiat Observatory, Gemini meteor shower observation. You go there in person to observe, Pulau Betong, 14th of December. Okay. And then on the 18th of December, I think never mind. Okay. Then we go to another one.
So Chong, I think for the December one, we announce next month.
Okay, so we
announce the next month airport. Yeah. We focus on the November one first.
Yeah,
and something interesting about the November airport session is we are going to have the first woman presenter in the panelists. We have done airport for so long, so many months. Almost one and a half years.
Yeah. When is it? What date of November?
27th of November, right? Next airport, 27th of November.
Yeah. Boon Wei.
Yeah, we have done this airport for so many months, but all the time we have men presenter. Now we have the first woman presenter will be joining us.
I hope she's not watching now. You give her the most interesting picture to explain. I never use the word toughest picture. Give her the most interesting picture to explain. Very good. Okay. Of course, we are still waiting for the second woman presenter, want to be interviewed, our Sabrina, on meteorite collection. Our Malaysia's own meteorite collector. She was unable to present 26th of September. So we hope, of October, we hope that she can come later. Any other questions?
So I think we don't have questions. So maybe we can just wrap up and then we end the session.
Okay, just one more thing. So again, you look at me, we are waiting. What? JWST. So now it's no more in maybe 3 or 4 years from now. No more Hubble. No. Back. James Webb Space Telescope. 18th of December, launched from the Kourou, Guyana spaceport in South America by the European Space Agency, and it will go into the what they call the halo orbit, right, of the L2 Lagrangian point of the Earth and Sun system, where it can observe the universe in infrared. So we hope that when it's launched, it will take another 30 days to go into orbit, and finally another 6 months to test. So sometime in the middle of next year, June, already, I hope we're working what they call work well. Because the astronomers are already using big words that if everything goes according to plan, they will have to rewrite the astronomy textbook. The discoveries are very fundamental. All right? Now, why? Infrared can see further, closer to the Big Bang. But unfortunately, the power of James Webb is not that powerful to see the Big Bang itself. So that's the ultimate, see the Big Bang in future. Now it's closer to the Big Bang. Okay. 18th of December. So I've spoken to Junjian yesterday. So So if it is okay, we would like to do the before the launching a discussion of the James Webb Space Telescope launching and what is the science they will bring. Although Dr. Derek Lin and I have presented earlier, but the December 18 one is more about the launching of the James Webb Space Telescope. It's now already in the laboratory in Guyana Spaceport. They are now assembling it. They are now integrating it into the payload section of the Ariane 5 rocket, integrating. A lot of work to do, no, and testing, no. So many of the Northrop Grumman company scientists and technician engineers are there on site now doing all the integrating. Okay, yeah. 18th of
Okay,
December.
so I think we can call this for a session for this month. So
Yeah.
we see every one of you next month. So thank you for joining us for our APOD session. We see you next month for our APOD on 27th of November. So thank you, Dr. Chong. Thank you, Zhe and thank you, Zhen Yang. Right, and thank you,
Thank you,
everyone.
Lai
Have a
Hong Jun.
good night.
Thank you, Michael, Zhe Zheng Yang.
Bye bye.
Okay. Bye bye. Good night. Okay.